Welcome to my friends online watching via Channel 9 with the live show there. My name is Tim Huer. I am one of the program managers on the Windows XAML team. And I say one of, obviously many teams here at Microsoft have a lot of people that build the products. Ours is no different. We have a great team building XAML UI framework for you for Windows 8. And I'm just one of them and here to talk with you a little bit about it. You've seen this chart a couple times now. This talk is going to focus primarily on XAML, not any new C++ isms. We have done a few things for C++ developers to make it easier to write XAML, and we wanted to share those with you. How many people have written MFC before? A lot of MFC folks, okay. So hopefully you will be happy about Windows 8 and a UI framework that is consistent across the platform that's available to you. Now, what we're going to do for the duration of this session is we're going to walk through an introduction to XAML, talk about some of the core fundamentals that our team feels is important for you to understand, and concentrate on the UI framework. We'll also demonstrate creating a Metro-style app using C++ and XAML in Dev 11 in Visual Studio, using the consumer preview bits, and talk about some of the tools that are available for you, how the VC projects, the Visual C++ project system has changed a little bit to accommodate this, and what are some of the Metro-specific things that you need to know as an app developer to understand how it's going to interoperate with the system. And then we decided to take a deeper dive into two aspects for the C++ crowd today, specifically data binding and data binding with ref classes and your data, how you can expose your data to the UI framework using the binding syntax and a concept of using data templates. And then secondarily, one of the greatest benefits of XAML is kind of our control framework and how you as a C++ developer can create reusable controls for your applications as well as to be distributed to other WinRT XAML applications. So let's talk about what exactly is XAML. So XAML is one of the UI frameworks. As Herb mentioned, there's kind of three ways you can build UI in Windows 8 Metro-style apps, one being HTML and JavaScript, the second being XAML specifically, and the third being DirectX, which can also include XAML, which we have a session later on today. So XAML itself is a declarative UI framework. XAML stands for Extensible Application Markup Language. It's been around for quite some time. It gets its origins from Windows Presentation Foundation, and we have a couple iterations of XAML available for the Windows Phone. Silverlight is based on XAML. There's actually other products, other non-UI products at Microsoft that leverage XAML as an infrastructure. Windows Workflow Foundation actually uses XAML to describe some of their orchestration, etc. But primarily it's a declarative UI framework that uses markup to describe types. And whenever you see that markup, you're not only describing the type, but you're actually instantiating it as well. So whenever you see this visual tree, whenever you're reading documentation or hearing people talk about XAML, you hear this concept of this visual tree. You can liken this to a DOM in HTML effectively. So the markup language is going to describe this object graph or this object tree of UI elements and in some cases non-UI elements. And then the two areas that we are going to dive deeper on is that the framework allows for also a very declarative way of data binding data and other UI elements combined together, again, using a declarative model rather than always having to rely on code. Now, we're going to talk a lot about using the declarative nature of XAML. It's not a requirement, but it is one of the benefits that we have of the framework. And then we'll show some of the flexible template mechanisms here. Now, I wanted to make this clear for this crowd today. So when we talk about XAML and native code, there's been some misconceptions about at build, especially when people started seeing the hat syntax in C++, that the CLI was involved or CLR was involved. So everything that I'm demonstrating today is 100% native code. There's no CLR bootstrapper. The language just happens to look similar to CLI syntax, but if you look, we'll load it up. We can look at the DLLs that are being loaded. This is D2D, hardware accelerated. There's no CLR involved. So this is not, some amalgamation of Silverlight jammed into native code to make it work, and all of a sudden there's a CLR VM running. You can, of course, write C# XAML applications. What we're talking about today is 100% native code. The XAML framework on Windows 8 has been refactored to use 100% native code as well, whereas in some of the other implementations, there's a mix of native code and managed code. So we talked about the declarative UI nature. You'd like to use the concept of a button. It's very, very simple to get across from an API standpoint. So if you've never seen XAML before, the top row is XAML. Looks like XML, right? It's exactly what it is. So we are declaring a UI element, angle bracket button, and providing some attributes to it. That is basically the equivalent of what you see in lines of code. So using the declarative nature or writing those lines of code will net the same result on the UI. And it's just kind of a good picture to show that the top line represents essentially a ref new, if you want to think about it that way. So every time you have angle bracket foo, you're instantiating that object in your application. And you can use it, again, you can use it through code, or you can set attributes there. You'll find in most of the XAML elements, we have kind of a intrinsic property or a default property called content. Button is no different. You can see that the button content is click me. You may say, why isn't it the text? One of the benefits of XAML is that we have this concept of content controls where it doesn't have to be text. Content can actually be anything you want, any other UI elements. And this is part of the flexible templating mechanism that I'll demonstrate in a few minutes here. With connecting to code and events, a button has a click event, right? So an API of any event, a button has click events, list view have scroll events, selected items. All these things will still exist in any control. So when you want to actually tie code together to those UI, we can actually do the code specifically itself and add these to the visual tree. Or we can use the declarative nature, and now let's say I want to add a click event to that button. Now you can see on the bottom here how we've added a new attribute to that button. We say click equal, and we're pointing to this named event. And so how we do that is we do rely on tooling. Most of the time, if you're using Visual Studio, you're going to benefit from a lot of this work for free. If you're a Notepad compiler type person, which is nothing wrong with that, you can absolutely do this. It's just going to be a little bit more work for you to wire this up. So in this example here, essentially what the tools do in Visual Studio, and we say XAML generates here, but effectively this is a combination of the runtime as well as some tooling. And the tools actually have two key parts, right? There's the Visual Studio UI element, the IDE, how you're interacting with your project and how you're interacting with files and changing attributes for compiler switches, et cetera, and adding files and designing the UI. And then there's actually the compilers. And in XAML, we think of it as we have two compilers. We have the code compiler, but we also have something that we more commonly refer to as a markup compiler. And the markup compiler is something that is happening in the background most of the time. It also executes when you actually build. But in this example of where I say button xname equal test button click equal this, what the markup compiler is doing in Visual Studio is generating a partial class for you for that file. Let's say this file is on foo.xaml. And the class is now, we have a ref class called foo. What the markup compiler is actually doing is has created a partial class of foo and added we do generate code. So we've generated some code here to basically wire up finding that UI element. So you notice in the C++ code here, I just have test button and setting the content. So I'm not declaring test button anywhere in any header. How does it know? Where is it getting that information from? And that's the benefit of the markup compiler. So we're doing some of that work for you. These files are totally visible. If you are a person that hates code generation, do we have any of those in the crowd? Awesome. Okay. If you happen to be one, or if you have a friend, if you didn't want to raise your hand, if you have a friend that hates code generation, you can get around this. We don't recommend it. I mean, you're getting the reason why we have this is for some productivity. Now, one of the key things I wanted to point out here is how we do this is this xname attribute. This XName is probably one of the most important things when you're tying code to UI in XAML. You can think of XName as the unique ID for that particular scope of your XAML. So it's not universal to your project. Can I have two things called button 1? Yes, but not in the same scope. A page is considered a scope. So I couldn't have two things named button 1 in the same page. But that is kind of the unique identifier for that UI element that the markup compiler and we use to wire things up. I talked about the flexible layout engine. And so we have XAML not only as a UI framework for controls, which I'll mention in a second, we also have various types of panels, we call them panels, to help you lay out your UI. Is anyone a designer in the audience other than Rick? No designers. Rick, you need to step up, man. So this is primarily gets designers excited about how they can lay out the XAML and how they can control the layout of the XAML. And we do that through various types of panels. This example is one of the most rudimentary ones. It's actually, when you're creating new projects in Visual Studio, the default what you'll get is this grid layout. It's exactly what it sounds like, columns and rows. Other types of panels we have are things like Canvas, which also is exactly what it sounds like, kind of an absolute positioning. You own where things exist on the screen. But then atomically, we have other things. So if I want to lay items one atop the other or side by side, we have things called stack panels. We also have items controls and list boxes. And in Windows 8, we have a couple new UI paradigms and things like grid view and list view and flip view and all these other things that we're laying out elements that we're going to put in there. So this is a very powerful and very key aspect of XAML to understand. Most of the time, you'll probably be hopefully you'll be working with a designer, or you'll be using some of the design tools to help you create some of these layout aspects. So the core of any UI framework is the controls, and XAML is no different. The one thing that we've done that's been different when comparing to like Silverlight or WPF or the phone, actually it's probably a good comparison to the phone, where there's very much a prescribed user pattern, a prescribed user experience that's desired for these applications. Now, in something like Silverlight, where, hey, we provide the default Battleship Gray, and you can do whatever you want with it and make it your own. What we've done in Windows 8 and the Windows User Experience team has come up with this personality about Windows 8 applications. What is a Metro-style application? It's touch-first friendly. It has a specific interaction model. It has specific animations. It has specific UI styling. And what we've done in every one of the controls for WinRT XAML is that we've built all of that in for you. So you don't have to think about how am I going to match the default experience of a Windows 8 Metro-style application. You don't have to think about that. When you're using the grid view, you're automatically getting all the animations from the Windows subsystem that are the same animations that if a C# developer is using or a JavaScript developer is using. These are all from the OS. And we built these in to the controls to match the personality and to do a lot of the work for you. And one of the most important things we've done is to make this touch-friendly. A lot of the themes that you'll hear is design and develop for touch, get mouse and pen for free. And that's really a concept that you should think about. And so we've done a lot of the work to make all our controls touch-friendly, paying attention to hit targets and all the direct manipulation APIs and input. Now, all our controls are based on templates. Everything that I just talked about for you is this concept of a template. So a button to us is really just an API, right? You can think about a button has content. It has sizing parameters like width and size, or width and height, and it also has events, click, pointer down, these type of things. So to us, it's just an API. And what we've done by default is we put a template on there. And what we refer to as templates, and you'll hear some interchangeable words, but a template is usually a combination of a control template, which is kind of the structure or the layout, plus styles. So you can think of styles as colors or other types of attributes. Those two combined make up our UI default templates. So everything that I just mentioned about every one of our controls are based on templates, and we provide those templates for you. And the great thing about the UI framework is that you can change those templates and you can alter them. So here's an example of some of the new inbox controls for Metro style apps and their default personalities. This is a consumer. Actually, these are screenshots from the build. So consumer preview, some of the colors are slightly different, but effectively everything is the same here. So you can see you have some of the primitives, right? The buttons and the checkboxes and things like that. But we also have some new aspects, like I mentioned, flip view. Flip view is kind of a container that is very touch friendly, kind of like a photo slideshow type view by default. It's probably going to be the most common use case. But different things like progress ring and progress bar that, again, if you use the progress ring in HTML, you use the progress ring in XAML, it's going to have that same animation because we're getting that personality from the animation library of Windows. It's not our implementation and JavaScript implementation. We're getting that same animation and we're surfacing it to the controls. So all these controls are available to you as a developer, and these are the default styles. Some of them have data in them, of course. But these are the default styles that are available to you. That again, you're going to get that personality from the control framework for free. And you'll be able to accomplish some of the unique characteristics of a Windows 8 application. One of the ones that I'll demonstrate is semantic zoom, one of the more popular kind of user experiences for a Windows 8 application. So I mentioned control templating and how all our controls are based on this definition. And the definition, again, remember, is based on a control template, which kind of defines the visual structure, as well as styles, which are you can think about the attributes of that control. So these definitions are contained into something that is another common term you'll hear a lot about XAML called generic XAML. And we call generic XAML is this massive dictionary that contains all the definitions for all the UI controls. We ship that dictionary, we ship that as a resource in the Windows SDK. So if you want to see how we built our controls and how we style them and how we template them, you're able to do that. Now, you could open it up in Notepad as just a XAML file. Now, I don't know why you would open it up in Notepad, given the tools that we have for you as a developer and a designer. Now, what you want to consider when you do this templating is that templating changes the look and feel of the control, but not the behavior. So I can make a button look completely not like a button, but it will always act like a button. And the key here is that separation between a developer and a designer, which is one of our bigger principles in XAML, that we're able to create that separation, that the developer working at the API level can have a reliable framework that they know that they're going to be working with button click, and that's not going to change regardless of how the designer is tweaking the UI to match branding or some unique characteristic. And that's essential. And I put a note here. Hopefully Rick will appreciate this, right? So the control templating model we have is not a license to abuse, right? So we don't need every rounded corner and every button to be a gradient fill or anything these days. Especially when you look at the Metro style, it's very distinctly different. You can do that. I always use an obscene example that your button template could be a movie that's actually playing. I don't know why on earth you would want to do that, but our infrastructure allows you to be that obscene. But please don't do that. So as an example, this is actually one of my favorite examples. I'm showing a video because we're using the consumer preview, and this particular one, I just didn't want to taint the demo machines here. But this is my favorite styling demo. To set it up, what you're seeing here is a list box. This happens to be a Silverlight application, but the concepts apply. I'm not showing any code here, so it doesn't matter. This is all done declaratively. What you're seeing here is a semi-styled window with a list box. The list box has been bound to certain type of data. Let's call this data is basically a list of colors. How many times have you gone into Home Depot to remodel your thing and you see all those color swatches, right? Think of that as the data. I have an individual swatch, and in that swatch has different hues of red or something like that. That's currently the data you're seeing represented in a list box. What does a list box have as a developer, right? A list box has a collection of items. I can have selected items. I can have multi-selected items. I have events that when an item selection has changed. All these things are no different. So I'm going to start playing the video here. And you won't be able to see some of the finer details, but some of that's irrelevant. And so what we're going to see here is, this is blend. This is a blend. I'm going to go in here, and on the list box, I'm going to apply 2 templates. I'm going to say, hey, for each one of the item templates, I want to have this specific style. And once I've done that, that changed the individual items. Now I want to say, I want to lay them out differently. I don't want a list box. And now I'm just going to apply a second style about how I want that panel to look. And now let's run the application and see, instead of, here's the normal list box, right? It looks like a list box. I scroll up and down. Now if I look at it in my new style, that is a list box. The behavior is completely the same at the API level. The user experience is so drastically different and unique to this application. And that's that is the huge benefit of the control model in XAML, that Rick as a designer can go in and make this user experience, both UI and behavior, right? How the interaction model is with that data. I, as the developer, I know that I'm dealing with a list box. I have a collection of foo, I'm binding it, and none of that has changed, no matter how many times my designer changes the user experience. That is the key fundamental that I hope to get across to you about understanding the control templating model in XAML. Now, the definitions can be verbose. If you look at that generic XAML, you'll see that they contain control templates, styles, visual state definitions, animations, and they can be verbose. If you want to use a text editor, I say that's great. That's for a task for people with a ton of time on their hands. What I'd recommend is that you use the tools that we provide for you, both in Visual Studio and in Blend. Now, both of these tools are there for you to be a developer as well as a designer. How we like to separate things is we look at Visual Studio as kind of like the coder tool, right? Its main focus is writing code. You do still get a visual design surface for XAML, but its primary focus is going to be the XAML editing, the text editing experience, the C++ coding experience, other things like an object browser, debugging, and IntelliSense in the code. Whereas Blend is more of the design tool, which is that one that you just saw there, where it allows us to better create animations, have a richer experience around editing the control templates and styles. And it still has code support, but it's going to be more minimal code support. And what we see almost all the time is that whether you're a developer or a designer, you're most likely going to have these tools both running at the same time at most given project cycles. And what you'll see in Dev 11 in Visual Studio is that we've taken a lot more of the Blend functionality and brought them to developers. There's still some unique characteristics in Blend, especially the rich template editing animations. But a lot of the same features are available in Visual Studio as well. And in fact, they share the same code base. So you're actually, under the hoods, you're working with the same product. So let's take a quick tour of this real quick and what we've done here. I have, this is Dev 11, the consumer preview. This is Express. Everything I'm doing is a part of the Express product. Express ships with everything you need to create a C++, a XAML application, DirectX application, and also includes Blend as well. A lot of people don't know that. Actually, after this session, Navit on the Blend team has a recorded session, one of the ones that Jaime was referring to, which goes into much deeper dive on Blend. I'll cover some aspects of it, but not to do it full justice here. So let's create our first C++ application. One of the things I wanted to call out, if you haven't seen this before, is we ship with a set of templates to kind of get you started. If you're the kind of guy like me, give me the blank application, get out of my way, I want to do everything on my own, you have that option. And we also ship with a couple other two that you'll probably see referred to quite a bit in shipping applications from a UI concept, this concept of this grid view application or this split-based view application. And let's take a look at the grid application here, and we'll just take that. Let me point out some characteristics of the project system here. So this is Visual C++, and we've done a couple things for Metro-style applications. One of the things that we've done is, first and foremost, because XAML is new to C++, we've obviously enabled it in the project system. Now, one of the things that's usually familiar for XAML developers is the relationship between the code and the XAML is, at least at the view level, is usually pretty coupled. And so what we've done is in the IDE, we've kind of wanted to show that relationship. So we've created this nesting hierarchy here that for every XAML file, you have the header file as well as the code file that's associated with it. Now, if this is just an attribute of Visual Studio, it's not, it's just kind of depends on attribute. If you don't like that and you want to do the show all view aspect, you can still do that. This is what we feel is familiar to existing XAML developers who will likely be coming to C++ as well. And so that's something that we've added there as well. The other thing for a Metro style application, you have, there's this new concept of this manifest declaration. Now, it's not as one-to-one as you would think of like a manifest that you would embed in your application. This is a manifest that's going to essentially describe your application package to the store as well as to your users at deploy time. This is a requirement of Metro style applications. It allows you to kind of just define the metadata for your application, as well as probably the most important thing in here is the concept of capabilities. So because we operate in this app container, this environment that is secure and trustworthy for users, you have to declare what you want your app to do. So by default, you can't just all of a sudden interact with the GPS on the device. You can't just read and write user files. You have to declare, hey, my application will want to access location services. And in order to do that, I have to declare that in the manifest. And that still only declares the capability. The user is completely in control of their system and can deny your app that right. This is essentially just saying, my app is awesome. The Bing Maps app, right, has this particular capability. My app is awesome. I want to use GPS. Hey, user, can I use GPS? And the user can still say yes or no. They're in complete control. But even for them to even have the capability to say yes or no, you have to declare your capability of your application. You can see some of these other ones as well, webcam, proximity, any of the document libraries that you want to access as well. Other things that are in here are some of the contracts, which we'll show here, that you can edit through this manifest. But most of this is really just metadata. What is my package name? How am I signing the application? How is it going to be displayed? What are my logos for the tiles and things like that? So that's this file right here. It's a requirement. So when you see it in your C++ project, you'll know that, hey, I'm in a Metro style application, so I'm required to have this information here. Now let's open a XAML file. Now this is the default view of XAML here. Let me build the application. We made significant perf improvements and changes to this experience for C++ developers. No space left on device. That's no bueno. Let's hope we don't get that again. But the default view that you saw there when you open up any XAML file is you'll see a split view. That view is controlled by you, but it's a split view where it shows the visual design surface as well as the XAML editing experience in the view. And you'll see that you have two tabs here. You can actually change it to horizontal versus vertical if you'd like. So the top will show the visual representation of what is being edited on the bottom. One of my favorite things that people don't realize is if you just double click on the tabs right here, it makes that the full screen view. A lot of people always try to mess with the grid splitters, but if you just double click on the tab, it's there. So I can go in here and select items, and you see that it's selecting them in the tree here as well. A couple other things. I mentioned the visual tree. This is the visual tree for that page. You can see it is a DOM, essentially. So it acts like a DOM. We can go in and select these individual items. Other things that are of benefit to you here is this platform pane. Let me just lock this here. Now, I have this particular view here, and this allows me to say there's different views in your Metro style application, right? There's the full screen view, but there's also what if I'm portrait or landscape. So what the Blend team has done is actually change the design surface here to provide a UI on what it will look like. So I can say, hey, what does my UI look like currently in portrait view? or landscape view, or what if I'm snapped? And so this platform device pane allows us to simulate those type of environments. Additionally, I can react to different resolutions. So I can go in here and target different resolutions here and say, how's my design of my application on a 27-inch monitor with some high pixel density there? Or I can turn some of that off and just want to be there. Change the theme. So there's different themes. Basically a light and a dark theme. So I can say the default is dark. What does my application look like on a light theme? And the design surface will show me that. So this platform pane is helpful as you go through your application to go back and kind of see how your design is reacting to different aspects there. Now, if we go into XAML, and if you're new to XAML, you might spend most of your time as a developer in the XAML editing experience here. And we have a rich IntelliSense capability here. So you can see that I mentioned layout there. So we're using the grid layout system. And as I select items here, the property pane here, the property inspector, will always change to those selected items. So not only do I have the designer, where I can get a graphical representation, I have the XAML editor where I can select things and get property panes, but also I have rich IntelliSense on every object as well. So both functionally properties as well as events aspects there. And that's, again, most of the time as developers, we spend our time in the XAML editing experience. And so you have this rich IntelliSense, syntax highlighted experience here. Now, let's say you had a device. How many people usually work on? I see some Macs actually. This is a good example here. You're developing on your MacBook with Boot Camp, or you have a desktop machine that doesn't have a monitor that you can actually rotate, or you don't have a touch machine. So one of the things we've done in Visual Studio as well is we're shipping with a simulator. So if I don't have a machine that happens to have touch or anything, I can launch my application in this built-in simulator. Now the simulator is effectively, it's a remote desktop session into yourself. And it allows for me to test a lot of the different things. So this is my application running. I can still do all the mouse behaviors here. But let's say I wanted to simulate touch. I can go in and say, hey, I want to simulate touch. And I get a different user experience here. And I can do the panning that I couldn't do with the mouse, right? So I can simulate a lot of those things. If I wanted to simulate pinch and zoom, so if I want to simulate pinch, I can go in. This particular application does it. But you can see I get this kind of two-finger approach. If I click and move the mouse wheel, I get this pinch and zoom behavior. Same thing for rotation, is that I pinch and then I choose the rotation point there. So if you don't have a touch machine, you can still test your touch experiences. And the simulator also has rotation for you, changing the resolution, simulating geolocation for something maybe you don't have geolocation on your desktop, capturing a screenshot for when you're ready to ship to the store. You go to certain points of your application, take a screenshot so that when you upload it to the store, it's available to you. So highly recommend using the simulator. It's one of the things that the team has put a lot of work into for you to be able to use for your applications there. Now let's create just a very simple project so we can see how some of the code interacts here. So I'm going to start with a blank application and close some things here. I've got the designer here, right? So I've got, this is just going to be my default grid layout. There's nothing in it from the design experience. And let's just go ahead and use our example of a button. And one of the things I'll show is that a button has a click event handler. And one of the things that Blend has done is, in the IntelliSense, they've also enabled this code generation for things like this. So as I typed in, yeah, go ahead and generate an event handler for me. And let me close out this button. You can see that two other files were open for me, right? The header and the C++ the code file. So I can right-click here and say, well, take me to that event handler. So in the code file, it's stubbed out the code for me based on the signature of the API. And in the header file, it's done the declaration for me as well. Now let's go back in and add, oops, accidentally deleted an angle bracket there. Now, I mentioned the relationship between code and content. And we'll add a text box. And we're going to add an X name to this, and we'll call it my text box. Text block, sorry. And so now if I go into this event handler here, and let's say when somebody clicks that, I want them to change the text of the text block there. Looks like it didn't do a background build, but did I change it? And you'll notice that I got no space left on the device again. What is going on here? Well, let's not kill any more time. We'll assume that this was right here. But what I wanted to show was that I didn't have any declaration of the actual text box itself in my header for that particular view, but I'm able to immediately use it in code. And the reason is because of that markup compiler that I mentioned. So I'm going to go to the Show All Files view here, and I'm going to go to these G files. The G files are the generated files that we create for you. So here's this partial class of that blank page. And if I look in the partial class here, you can see that here's where that declaration exists, and that's how I'm able to do that. And in fact, so if we go in the header of our page itself, by default, the tools will automatically always #include those generated files for us. And then at a higher level, what we do is we have this XAML type info file, which describes any type that is being used in XAML needs to be described in metadata to our runtime. What it is, what are the properties, how it is activated. And again, this is one of the code generation areas that we do for you in the markup compiler to make your life easier. It's a lot of code. You can implement your own metadata provider here, but by default, you're going to get a lot of this for free here. So hopefully we won't run out of disk space again. We'll try it again here. So the other thing is that we've heard a lot about Windows 8 user experiences, and what are some of the new UI patterns. And some of the things to keep in mind is that number one is that your application is going to be full screen, right? So these are content over Chrome aspects here. The app owns the screen, the user's in control. They close the app, they determine if it's in the snapped view, if it's rotated. You don't control that, the user's in the control. So you have to design for those adaptive natures. And then we have these new UI controls, a couple of which, actually, let's just go ahead and show them. And then the concept of contracts, what I mentioned. And so let's walk through a couple of these experiences. So one of the sample applications that you can download is this Contoso cookbook. So this is kind of looks familiar from that grid view application template, right? That's kind of the starting point of what this had. And so this is a grid view that's bound to some data. This is a C++ example here. And I can scroll through here. As I either right-click, maybe it's not on this particular screen. Let's go to a different one here. So as I go in here, if I right-click, or if I swipe from below, I get this concept of the app bar. This is XAML still, but this is a Windows 8 UI pattern here, is this app bar. And I can choose to do certain things in this experience here. I can just go home, or I can add other contextual specific commands here for this particular recipe. The flip view, this application is using flip view. So you can see in a touch experience how I'm just able to navigate. Now let's say I wanted to navigate that same flip view in a mouse experience. You should see that immediately when I hovered over with my mouse, I get mouse hinting. So we've done again, this is kind of designed for touch, and then get the mouse for free. So in a touch environment, you don't see those hints because I have the touch interaction able for me to do that. But in the mouse environment, I do. Now this is a lot of data, right? I can scroll and back and forth, and these are all in groups. How could I better visualize the group or see what are the groups rather than just scrolling? This is where another Windows UI pattern called semantic zoom comes into play. So I just pinched on my data set, and I got a zoomed out view of the same data. And I can quickly scroll in and say, let me see what's on the Italian menu, and go directly to that area. Zoom back out, go to French. Right, so this is the semantic zoom control, where you're basically providing a zoomed in view and a zoomed out view, and you have that touch experience. This is also mouse capable. Again, I'm designing for one paradigm, and I'm getting everything for free there. The contracts. So one of the things that I want to do is I want to search my application. Now this charms bar here is OS wide, right? This is not custom to my application. This will always exist. But if I want to opt in for search, I can declare that, hey, my application is searchable. So I'm gonna implement that search contract. And now when I type in Korma and type enter, it activates my application for search. We happen to be launched in the application already. But in fact, let's kill the application and go and say search. And you can see that my application is listed in this list box that it is searchable. So I can click that. And my application is launched as a search context, provides the parameters in there, and it starts at that point. And then I can go back in. So these are some of the Windows UI aspects that are built in for you, and that the tools make it easier to do for you as well. Now, one of the key aspects is the concept of data binding. And data binding is essential to the XAML platform. In fact, the key to a successful XAML developer is to fully comprehend data binding. Okay? This is probably one of the most important things in XAML, is that the concept of binding or either to data or other UI elements is fundamental to our platform. So we consider binding as a powerful way to connect UI and data declaratively. Your data could be a literal model of data, so some ref class, or other UI elements, right? So I can have my split view, kind of a master detail view. As I select things, the view somewhere else is changing, and those elements are talking to each other. Now, this is the binding is really used a lot to enable pattern development. So you may have heard, how many people have heard of MVVM, or model view view model? So it's a very popular development pattern for XAML applications. And binding enables that pattern very well to allow that clean separation between your view and your view model and your model. One of the key concepts is understanding this concept of data context. Data context is, again, we shouldn't always think of data as, a list of rows. Data can be a single object or a UI element or an UI element. But data context is how the UI framework is aware of that type. You're basically, that list box example that we showed, the data context for that list box was the collection of foo items. But a data context could be a single object. A data context could be another UI element. The relationship of the binding engine really relies a lot on this concept of data context here. So let's do an example. Let's just jump in. An example of how to do some data binding. Some simple examples here. And hopefully the demo gods will be with me. So I've got this very simple application here. And what I'm going to do is see if I'm able to build first. Okay. I'm going to add a stack panel here. And the reason why you're not seeing IntelliSense is because it's consumer preview. And we will add a couple text blocks. And we're going to use the text property here. Now, this is going to be the UI that we want to show here. We want to show some specific UI here. That could be the problem. I feel like some log file is, yeah, it's not going to, this is not going to end well for me at all. Okay. Is Jaime here? Okay, we're going to run out of disk space in like 2 seconds. I don't know if the crew might be able to assist me in getting my backup laptop ready as I'm talking through here. Let me just start talking through some concepts here because I feel like I'm cursed. So what we're going to do here, and in fact, let me just start showing some code here. So this represents our UI. And then we have this person object here, right? So I've got this is a public ref class, and I've got this object that has two properties, a name, a full name, and an age. And I want to expose those and create, I want to bind some UI to that. So I could go in here, and I've created this declaration of myself in the page here. So this property called myself. So I can start setting properties and say my full name is Tim Hewer, myself, age 38. So then let's say I have that object. I can say for my UI element, and in particular this page, I want to set the data context to that object. So these 3 lines of code is I've created a type. I've created an instance of the type of people, just happens to be called myself. I've set some properties, and then I've said, hey, the data context of the page, I want you to be this particular object. This is not an iteration of objects, but this is a single object. So now how would I get these bound to the UI aspect here? Well, I go back in my XAML here, and I could say, the text, I want you to do some binding. And the path I want you to use is this property called full name. And I can do the same thing here. And this binding to this age here. So what I have here is this binding statement. Now you can see that I've got this visual tree. I start with a page, I've got a grid, I've got a stack panel. And I've set the data context on the this object, which is the page. Now one of the benefits of data context is that wherever it's set high in the tree, that data context propagates down to the visual tree. So even though I've set it here, the grid is getting it, the stack panel is getting it, and thus my text blocks are getting it. So I'm able to pull out that path from that specific object and bind those UI elements to it. You'll usually see a shortcut mechanism that looks like this. So by default, path is implied if you don't provide any other things. I prefer to be explicit. I think it's a good coding practice for code maintenance and other people that are looking at your code to understand what the path is. Because I could also add things like converters. I can say, hey, I've got a converter called foo that basically is going to convert my age, minus 10 years and make me younger or something like that. And then the converter would return the result there. So using the path equal is an explicit mechanism there. So if I were to run this application, I assume I wouldn't be able to because it probably will run out of disk space. But what you would find is that I would actually see no binding at all. The UI would show nothing. And that's because the XAML framework is not aware of anything about this type, right? Your code is, and your code's able to use it, and the compiler knows about it. But the UI framework has no concept of what is the type information here? What are the properties? What is the metadata of this type? So one of the things that we can do is we can add that didn't help, man. Yeah. Well, let me just talk through this. I don't want to be sensitive of time here. So what I can do is I can add this implementation of this interface, which we enable called iCustomPropertyProvider. And I can implement this interface and all these properties that describe what are the type information that's available to a given type. Now, I only have 2 properties here, so how many people think this is a lot of code? Okay. So what we've done to, we agree. So what we've done to make this easier for you is allowed you to do this. Instead of having to implement that interface, on any public ref class, you add that attribute, and we will do all the work for you. So by adding that single attribute, the runtime will now be able to and be aware of to inspect that property on any public ref class to be able to bind to those elements. So we think this is a great productivity enhancement, and hopefully, let me just try to run this. Everybody cross your fingers. Access violation. Where am I? Well, if it was successful, you would have seen it. So what we allow by doing that is we do a lot of the hard, heavy lifting for you to bring that definition of that data and allow you to write simpler code and be able to apply that to your UI. Now, the other concept in binding is the concept of data templates. Now, let's say I had a representation of, instead of just one people object, let's say I had a list of people, right? So I had a person class, and I want to bind a list box to a group of people. So I could say my peeps, and I'll just type this out here. And so for each control, I have different properties I can use. For list types, we have this concept of an item template. And each of these item templates can have a data template. So what I can do here is take my definition of my individual item and just move that to the data template. And so what this definition you're seeing here is now, as I'm saying, I have a list box. List box is just going to be able to bind to a list of items. And now it's going to say for every item template, for every, item that you see in here, you're going to apply this data template. And you see that it has the same definition that we had before and the same binding information. So now in code, I could basically go in and say, hey, for this element, I could say my peeps item source is going to equal, let's say we had our people class. Man, this is not cooperating with me. So if we had our people class, which would be a vector of, of type person, I could create an instance of that and populate that and set the item source of a list item to a collection of items, and that when the binding engine sees that, it's going to apply this data template to each one of those items. So I can do this. I can do binding on an individual aspect, or I can do it on a list of items as well. There's something there. Yeah, not sure. Yeah, let's try that. So one of the other aspects of binding that we can do is, I mentioned UI binding. So not only data coming from some data source, and really the data source is irrelevant, right? It could be something from a web service, something from local storage, some operating system type or something like that. We're going to hydrate that into some class that we're going to bind to. So what I can do here is I can also do UI element binding. So I'm going to add a slider here. And a slider is just a visual element that does exactly what you would expect. We're going to add a minimum value and a max. And then I'm going to add a text block. And this time I'm going to bind two UI elements together. So I can use my same binding but I'm going to say, hey, you're going to get your value from this thing called mySlider, and on that object, I want you to get the value element there. So using this syntax here, this element binding is I'm binding UI element to UI element here. Now this is a simple example of a slider, but you could think of a more advanced as a master detail where the list box is my list of customers, and then I have a detail view that's going to show the detail of those customers. So my detail view could say, hey, you're going to get your information from the selected item of that list box, and that data context will now transfer and flow over here. But if this is able to run, we can just see a very simple example. So I've got my slider, I've written no code, and I'm just using declarative binding, and you can see that the UI changes. Again, a very simple example, but it's able to work correctly. I can show you some more demos. I'll be around all day, so we can get my other machine working and show you some more advanced there. So to sum up on binding, as again, it's a key fundamental of our framework. From a type standpoint, you have two mechanisms to doing it. The first one I showed you was a pretty verbose iCustom property provider implementation. And then the second was simplifying that to using the bindable attribute. Now there's absolutely valid cases for iCustom property provider. So we don't want to discount that, and we're not deprecating that. That's still an available API to use for you. In fact, using the bindable attribute requires you to follow some certain rules. Namely, your class has to be a public ref class. So that's the only thing that we support in bindable. So if you have private types, you're not able to use that bindable attribute. And this is where ICPP is helpful for you. So it's still extremely valuable. There's some of the other use cases that you can use it for. So if you have classes that have indexers, you're going to use that interface. Whereas bindable is more of a very simplistic approach to certain things. Now the second aspect is this concept of custom controls. Now when we say controls in XAML, this becomes an overloaded term very, very quickly. You'll hear people refer to controls just kind of universally, when in fact there's really two kind of clear cases of types of controls. There's one that we call user control, and in fact almost all of the page elements and those type of things are derived from user control. And user control is meant to serve as a composite of existing elements. Primarily, you see user controls as kind of encapsulation of certain UI aspects of composite controls in a single application, right? These are controls that are not themable. So you remember I showed that example of control template and styling. That's something that you can't do with user controls. And they're also usually not redistributable, right? They're applied to a specific project. Now contrast that, which we refer to as a custom control, which is everything encapsulated logic and UI and animations and control and style template in a single package. You're already using custom controls if you're using XAML, right? You should think of button or any of the included ones as custom controls. Anything that ties back to that generic XAML is a custom control. In fact, that generic XAML is that concept. So when I create a custom control, I'm creating a generic XAML, which I'm going to provide my default definitions. Now, this is where you would create reusable components that you could distribute to other people. XAML has a huge third-party ecosystem around custom control development. We fully anticipate that our control vendors for WPF and Silverlight will soon step up and be providing WinRT controls as well. So Morton happens to be in the audience. Morton's a friend of mine. I like this statement because it's very true. So custom controls are a very underrated mechanism in the XAML framework. And when you think about encapsulating your logic, even within your application, or if you're spreading it across multiple applications within your own company or your own product, you should be thinking about custom controls over user controls. There's different ways that you can do this today. You can subclass existing controls. So I can derive from button and add things to it. Or I can derive from control and completely be responsible for that. So if I want to create my own panel, as an example, I could derive from control and override certain methods to create my own panel and UI. In Visual Studio and C++ specifically, every control that you'll be creating is actually a WinRT control. And the benefit, this is different than C#. C# can create WinRT controls, but most of the time we see C# developers as creating managed components that are only for managed applications, which is perfectly fine. In C++, you actually get the benefit because XAML is a WinRT type system and everything that you're creating will be a Windows runtime component, that your controls in C++ become instantly reusable, not only in your own projects, but to other people as well as C# developers. So if you're a component vendor and you're looking to get the most breadth out of your control, using C++ is a good way to think about that. When you create a Windows runtime component and you add a templated control to it, you've just instantly made it reusable to not only native developers, but also to managed developers. So let's see if we're able to do a quick example of that. So how would I do that here in Visual Studio? Well, the first thing I'm going to do is I'm going to create a WinRT component. And we'll call it Tim Control. Actually, and I don't need some of the defaults here. I'm just going to get rid of these for a second. So I have this WinRT component here. And Visual Studio gives me a lot of, we've talked about project templates. For XAML, we provide a lot of item templates too. In fact, one of the things that I mentioned about the share contract, right? I can immediately just, or search contract, I can say add new item, search contract, and it will implement the contract for me, decorate the manifest in the appropriate manner, add the correct activation APIs, etc. So you should look at those as well. One of the ones that we have is this concept called a templated control. So the templated control is exactly is a custom control. So I'm going to create one called a labeled image. And this will do a couple things for us. So you'll see that it creates a new ref class for me, as well as it added that generic XAML. So by default, we give this, we put this template here. This is just a very default template, which is just a border with nothing in it. For sake of time, let's just add just some text in this. So this is a border with just some text in it. And that is our, this is like absolutely the most simplest generic XAML definition you'll ever find, frankly. But this is, so now we have this custom control here. And I can build this custom control and actually need to do, and now I've just created I've created a WinRT component that I could distribute. So we'll see if let's see if we're able to use it. I'm guessing no, but we'll try. So now I have my C++ application. I'm going to set that as the startup. And now I'm going to add a reference to that custom control. I'm going to show you how you can consume it. So in my XAML application here, I'm striking out, man. Striking out. I'll be here all week. So what we can do is, how this would look, now that I have a reference to it, is every time you're using either a user control or a custom control, you need to provide like the name scope for it, or the namespace. And the way you do that is using this, this XML namespace declaration at any point of where you're using it. The most common is usually at the root-most point of your visual tree. It doesn't have to be. You can do it inline, but the most common is to do what I'm about to do here. And I can give it any arbitrary name here. So I can just call it Tim. And then I use the using syntax. So our namespace is Tim control. Now that allows me to do the next thing. I can say Tim labeled image. And we had background was red. We can say width. And by putting this namespace in here, it allows me to reference the class type that's in that control. And so now, if I had disk space in this ran, we would see that control render. Now, the good thing is that this, as I mentioned, because this is automatically a Windows runtime component, if I create a C# application as well, so I can go in here and create a C# application and do the exact same thing. So I can go in here and add a reference to the TIM control. You notice that it even shows up here as a valid reference. And then in my C# application, I actually would do the exact same thing. Now I've lost pointer. Awesome. There we go. I would be able to do the exact same thing. And I've written a control in C++ that's consumable in C++ as well as C# because of the WinRT type system. And again, by default, when you're creating a control in C++, you're creating a WinRT control that's consumable by anyone else. I'm not even going to try to run the other sample. Yeah, what the heck, I'm brave. We'll try this one, see if we can get it running. 0 bytes. I'm out. Oh, I'm going to blame those SQLite guys. Can I do that? I'm just kidding. All right, let's see if this got me any further here. So I want to show, I'll kind of end on this. So Jesse from my team is going to give a deeper dive on the DirectX XAML interop. But some of the things that this example, I call this particle man. This is just a super cheesy particle generator. But this is DirectX. The particle generator is DirectX, which is actually a custom control that I wrote, which derives from swap chain background panel, which is one of our types, and adds a new property on it to expose basically to data binding how many elements I want to the particle to generate. And now I've added XAML. So this whole screen is DirectX, but this is XAML, and this is bound to the property of that custom control. I can add a app bar. Again, this is XAML UI with DirectX, so I get that touch experience. I can jack up the particles there, and follow my my finger here. So this is kind of putting a pretty cheesy example on putting a lot of those concepts together here. And Jesse will definitely cover more of the aspects of the DirectX XAML interop. There's a lot more available to you in XAML and C++. Covered just a few of the areas. Apologize that we weren't able to get as detailed in the samples. Again, I'll be around. I'm happy to show or answer any questions. And in fact, maybe if we have a break, I can jump back up and do some of those. So there's a lot more to XAML and C++. Here's other areas that it's not just about data binding and custom controls. We, again, expose the animation library that the operating system does and make that available to you to use as a developer. On top of that, we have our own animation system as well that's storyboard based and that you can create animations for your UI controls. We are a vector graphics based system, so a lot of it, you can benefit from getting automatic scaling and using vectors for or path-based data for some of your UI elements. In WinRT, we've added declarative localization support, which is something that we're pretty excited about. Hope to get feedback on. It seems like people are liking that, but being able to just allow us in the parser to do the work to assist you in your localization. And then we also have expose, because we're a Windows component, we're able to plumb down to the media foundation within Windows. So we do have support for all media scenarios as well as text scenarios like rich edit. So you can use rich edit type behavior within your XAML application. And again, kind of our our huge feature around this release has been the DirectX and XAML interop, and Jesse's going to cover that later today. And I've kept a link in this deck for if anyone downloads it later that will go directly to his presentation. So just to sum up, C++ is a first-class language for us in XAML. There's no broker in between when you're using C++ and XAML. There's no CLR bootstrap that you're pulling in. It is WinRT, and when you're using C++, you are writing native code against native code. The UI, this is the primary UI framework for you as a C++ developer to create Metro-style applications that aren't full DirectX applications. And again, just to stress that we've done a lot of the work in our UI framework to make sure that we exhibit all the personality and behaviors of the Windows Metro-style platform for you to implement. And then, again, just to stress the 2 points that for folks in this room, I think that's important is really, really understand the data binding and the binding model itself, not only for data, but also for following things like the view model pattern and how it all relates to each other. And the controls framework. And you have the benefit that every time you're writing a custom control in C++, that you're writing it for everybody, not just yourself. There's some really great resources for C++ developers. On the Dev Center, all the SDK samples for XAML usually have the C++ counterparts. We're continually improving our coverage on the SDK samples. And when we do the release preview in a couple weeks, you'll see new samples and enhanced coverage on C++ as well across the board, not only for XAML, but across the Windows system as well. There's 2 sample apps that are really good reference apps for C++ and XAML. The Contoso Cookbook that I quickly showed is a very simple concept, but has great Windows 8 code and concepts with the grid view and semantic zoom and app bar and all those things built in for that. So that's a really good one to reference. Additionally, there's a project called Project Hilo, which is, if you've been around for a while, you might remember the name Hilo, has been a Vista application, a Windows 7 application, etc. It's been enhanced to be a Metro-style application. This is delivered out of our Patterns and Practices group. It's hosted on CodePlex with all the source code. This is a C++ model view model implementation. So if you're interested in how would I do that in C++, this is a good place to look. It uses a ton of data binding because of that. It also uses the C++ unit testing framework that ships with Dev 11 as well and has unit test coverage for the application. And then we always like to call out that existing XAML resources are still totally acceptable to use. So if you're trying to understand how do I do a concept and maybe you're not finding it in the SDK sample, please send me an email, and we probably have a gap there. But we also want to stress that the concepts in Silverlight and WPF still, from the XAML side of things, still carry forward to Windows 8 XAML. A lot of those tutorials that you see will still apply. Some of the APIs might be slightly different, and the implementations might be slightly different, but the concepts are still the same. So again, thank you for coming out. Apologies for some of the demo snafu, but happy to stick around and answer questions. And you can find me online if you have any questions. I'm always happy to make customers happy and make you successful. And our team loves feedback, good and bad. It helps us improve the product for everybody. So we're happy to take that feedback. So coming up next is a video from Naveed. I don't know if we're behind schedule and we're just going to jump to that. But again, thank you very much and apologies for the demo.
Yep.